Testing. Hey, how's it going? Just doing a test stream here for a second. See if anybody drops by. Okay, looks like it's running. Let's see. Let's see if people want to drop on by. Give me a second here. Toot. Can you all hear me? Hey, what's up, Mighty Sandwich? That's a good question. Are we gonna move on to the new version of Zig? The question is that gonna cause more roadblocks and it will solve any problems? Like, what will library support be like? I don't know. With the compiler, I've heard there's issues with miscompilations with the new um, fully self-hosted compiler. So the smart choice as far as a game development perspective goes is no, you probably should not upgrade this. But I will be looking into what's going on, just chatting about it, just to learn, see if in the future is it worth moving over. Probably not the initial release, which is again on this of the self-hosted compiler. Speaking of which, yeah, I don't know who knows what's going on with the Zig world, but yeah, they finally moved all their code from C++ based to actually being Zig based. So Zig building Zig effectively. That's as far as I understand it anyway. Um, yes, so I'm just going to review that real quick. We're not going to get directly into development of the game, but I will. This is more of a kind of casual, formal, unstructured stream, but hopefully I can take bits and pieces and put it into an archive for people to watch later. Um, well, that's a tricky thing with building any complex piece of software. You really want to lock to a very specific version of a compiler, a library, especially with games, because the behavior is so dependent on a lot of factors, right? Especially when you're talking about things like physics simulation, which really won't be an issue in our case, but it's just something to keep in mind. Also, things like performance, right? Performance in video games is super fickle, especially on PC. Like small changes in the OS and in the driver layer, you know, can have huge impacts on like input latency, right? I know like in the web space, people frequently update their software, but I just don't think that is an ideal way of going about things for game development or just, PC-based application development in general. So yeah, I'm curious, has there been any like new programming features implemented in this? Not just obviously the self-hosted thing, but has there been anything else that I missed? Yeah, language changes. This is what I'm interested in. Documentation too. So language changes. What do we get? Okay, let's just start from here. I'll just chat about it. Okay, in Zig 0.9 and the Bootstrap compiler, the type f in void is a function pointer and acts like a pointer. It's a function pointer and acts like as a pointer. Does that mean it just has a behavior of variable pointers, memory pointers? I'm not sure. However, the language spec, which is not written yet, will have the type be a function body type. It must be compile time known, okay? And in order to get a function pointer, you have to use asterisk const function void as the type, I guess. I guess as an example, it doesn't. I don't think it should have to return void, right? Wait, give me a second here. Yeah. The self-host compiler implements this correctly, which means your project will likely break everywhere that you use a function pointer. Yay! Because I do use function pointers for like the state machine. I think we did that right. Let's look at the code real quick, just to review. We have the state machine and the individual states and the common states. Yeah, we have like this inside this struct, we've defined multiple functions on start, on update, on end. I wonder, we've used that all over the place, right? So these are the definitions. We call it here by first checking to see if there's an on start set, which means the state object does store. It must have an on start. Can we go to this? Sorry. Yeah, it has an on start function, a property, a member called on start. If we go back here, we can see that, well, we're not actually filling out a particular function. Sorry, if a particular struct body, it's like we're making a new type for each one of these. So what were we doing? It's been a while, so I'm just trying to remind myself what we were doing. Well, combat states. Okay, so we had combat states which store enum to int, so it gives us, we've stored. So what is the type of combat states? Can we go here? Does it tell us what combat states is? I hope we can get improvements in the IDE so I can quickly jump to these things. So combat states is a combat state callback. Okay. Which has onStart. So yeah, this is an optional function returns void that takes a context. I wonder if that's fine. It's not const though. That's one thing. It's not const. So you see the self-hosted compiler here must be a const pointer type. Say, oh yes, right. So functions are now going to be pointer types. Here is an optional. Okay. So here's the problems we run into. Let's just check that out. Okay, let's talk about this. So we have a test code that just makes a const that returns the value of foo, I assume. And then, no, it is foo. It assigns not the value of foo being called, but actually assigns foo to s. And then you call s.fn pointer. Oh, no, wait, never mind. What is foo? Let's check it out. So foo returns s, a type s, and which is anonymous structure, right? A structure without any type necessarily. Well, I guess it does have a type. It has a type s here. And it just assigns function pointer to bar or baz depending on if it's runtime or compile time, I guess. Runtime is set to true here. Okay. So it's going to be bool or bar baz. So it's just a function pointer. The type of function pointer here is just function void. There's no const, there's no pointer. This is like what I've done, but I made it optional, right? It's just a function that returns a void type, which means it doesn't return anything. And you get an error here, looks like. Unable to resolve compile time value. If runtime. Well, that's an error for sure, but why is that relevant? I'm not sure. Okay. Anyway, condition is time branch must be compile time known. Expression is evaluated at compile time because the function returns a comp time only type test.s. So this type, I want to parse that. What does that mean? Expression is evaluated at comp time because the function returns a comp time only type. So test.s is a comp time only type. This is a comp time only type. Comp time only means you can't use it at runtime. Okay. So struct requires comp time because of this field. Oh, so it's an implicit property because the struct requires comp time because of this field. Function pointer function dot, and I guess this is unknown at comp time, right? So that's a problem. It says use const function pointer to const function pointer. I think that's how we should read it. Const function pointer for a function pointer type. Not this. Okay. So the solution becomes obvious upon reading the compile error. You just make it this type. Yes. Okay. Well, that's pretty much that. So what we've learned is we have to define function pointers as asterisk const fn, not fn, not what you would expect. I'm not sure why the language specs has it that way. I guess it's the difference between comp time and runtime. So this is a runtime reference to a function. This has to be known at comp time, and it's not known at comp time because there is a runtime branch that's happening here. Here would have been fine. So you can still, it looks like you can define things at comp time. So I guess if the problem is optional, so I don't know if I don't know if that's gonna work. Yeah. Okay, I'm not a language expert, so I'm just gonna leave that it as and accept it is that way, not think too much about it. So pack structs. This is important for game development, by the way. So in previous releases of Zig, there have been some nasty bugs that unfortunately did not get fixed for a long time, resulting in packed structs having a deservedly poor reputation. Finally, the situation is resolved. Packed structs have been reworked both in terms of the Zig language specification as well as the implementation. So if you don't know, packed structs are just a way to get rid of any padding that you have in structs. For particular reasons, I'm not going to go into. Compilers will insert additional padding between properties in your struct for alignment issues, things like that. You can go look up why. I think even in Zig documentation, they explain quite a bit why you tend to have padding inside of your structures. But pack structs mean you kind of put all the properties together without any padding in between. Obviously, smaller size, great. It's much better for cache coherency. Cache optimization in video games because you're fitting less memory into cache. You can fit more objects, more structs into cache lines because you don't have that wasted space used for padding. Okay. So let's just see what they're saying here. Now, one can reason about pack structs in a similar way as one reasons about enums. That is, they are merely integers wearing fancy hats. Okay. So their underlying type is integer. Each pack struct has a backing integer, so yeah, like in C++ underlying type, which defines the ABI of this type as well as the memory layout. The backing integer can be specified explicitly or it can be inferred from the total bits of all the fields. So that means, I guess, if you have 32 bits, well, you have a 32-bit integer as the backing integer. Same would be 16 bits. Why am I using Zig as opposed to C++? Well, first of all, I think Zig is a much simpler language than C++, so I think it's just a overall better language for teaching. But I have a personal interest in learning Zig. I looked around for a bunch of different new languages that I think are really fundamentally trying to like solve a lot of problems Zig, sorry, that C++ has had for, in my case, game development, just out of sheer complexity. And I just don't want to introduce that complexity in these videos. And I just have personal interest in learning new languages, so I thought, hey, it's a good opportunity to use Zig. Like I was thinking originally I was thinking of using Zig or Odin. Odin's another language along the same lines of this. I think Odin in particular has actually designed by a game developer. Or at least he makes tools that are targeting like games and the special effects industry using it, or it's like part of a tool. I think it's some kind of VFX package. But I just settled on this because a few different language aspects. One of the big ones being that the compile time code is the same code. It's the same syntax effectively as runtime code. You don't have to learn a special template language like you do in C++. You just have to learn the rules of what you can use, what you can't use. It's just similar to parts of the newer C++ spec where you have like const eval, const eval if, I think, things like that where they get run at comp time. That was the main thing that interests me, because in game development, you want to do as much stuff offline as possible. So things like reflection, things like generating parsers for your data types. If that can be done at comp time and not done at runtime, it's going to be much better in terms of speed of loading things, obviously runtime execution. You don't have giant lookup tables that completely thrash your cache and stuff like that. So yeah, and there's other reasons, but that's a pretty frequent question that comes up. Yeah, so backing integers. Okay, so look, we got a pack struct here. I guess you define it using the syntax pack struct. Pretty simple. You give it underlying type of U32 unsigned 32-bit integer, and you give it, and then you have an A, which is 29 bits, and B, which is 2 bits. Adds up to 32. Pretty clear. And then you just test it by creating a new variable that is this struct type, A assigned to 1, 2, 3, 4. That should be fine. 3 should be fine. 3 is 1, 2, 3, 2 bits. So we are good there. Clearly 1234 fits into 29 bits, so that's fine there as well. Oh, so this is actually an error. This must be the old type, I guess. Okay, backing integer type U32 has a bit size 32, but the struct fields have a total bit size of 31. Oh, I misread this. Yeah, it's 31. Okay. Yeah. Huh. So the fields are specified in order starting from logically least significant and ending with logically most significant within the backing integer. The backing integer is stored in memory with the same edness as equivalent integer type for that target. Makes sense. This makes Zig's pack structs have a well-defined memory layout, unlike C, where the memory layout is implementation defined and therefore usually cannot be relied on. So that's a pain in the ass when you're like trying to support different platforms. Your binary data may be loaded differently. I won't tell you what particular game it was, but I was kind of looking into the binary data for 2 versions of the same game. One was on the Xbox 360, and the one, or maybe it was PC, and the other one was on PS3. The idness was different, so the parser I was implementing had to account for the different platform idness, basically flipping or reading the bytes in different order. And that sounds like, of course, idness is an issue, but yeah, it can be implementation specific. So in the near future, the syntax will change to avoid confusion with C pack structs, which is a different concept that relates to padding. So that's what I thought it was as well, because I'm used to C style padding. In Zig, such a struct is done by using extern. That's a kind of interesting name for it, and setting each field's alignment to 1 byte. Well, that's more logical, actually. So you have a struct that has been marked as extern, and then you have, looks like you got a 64-bit field and an 8-bit field here, both with alignment of 1. Okay. And they just assert that the size of of the second field? Sorry. It's 18. What is this exactly? So S is the type. Why is it 18? What am I missing here? Sorry, I'm gonna remind myself what the size of keyword does in Zig. Because I want to understand what that is. Is this master? So I should get size of, yeah. Size of. This function returns the number of bytes it takes to store T in memory. That's what I thought. Oh, so it's bytes. Sorry. I'm thinking of bits, apparently. Hey, Mr. Duder. How can I deal with this? I'm not logged in. That's why. Okay. Hold on. Wait, can I do this with OBS? What does this do? Can't do anything with this. OBS doesn't really help me. Crap. Okay. Okay. What? Alrighty. Alrighty. I should be able to handle that now. Yeah, what is this? How do I deal with this? Okay, yeah, give me the mod view. Okay, yeah. Alrighty, how do I deal with this? Ban. Should I ban report? Ban. Okay. Goodbye. That's what I needed. Now we're done with that. Continue. Alrighty. Okay. So that should be 1 plus 4, 8. Why is it 18? I'm sorry, actually not sure what a 2 before identifier for struct does. Is it because there's some kind of padding involved? What does the 2 do? I'm not sure what the syntax is, actually. Oh, okay. Well, I'll learn about that later. Moving on. Inline switch cases. The inline keyboard can now be placed in front of switch cases. This effectively turns a runtime known value into a comp time known value. Pretty straightforward. It sounds like what inline would do. So you got a switch here, and then you filter 1 to 100 as X. So you pass in 1 to to 100, you get X. It prints foo. Otherwise, not in range. It panics. Okay. Bunch of stuff here. Then the foo function requires comp time number. Length of array. Okay. So you pass an array and do, well, sorry, because it's 4. Yeah. So every element in the array, you cast it. So that's a comp time thing. Cool. Dot. Okay. I'm going to read what they say because I'm not entirely sure what the syntax does. In example, we take a number that has passed in as a command line parameter at runtime and pass it to a function that requires a comp time parameter. This works because switch gets inline. So we have 100 prongs are generated similar to unrolling, I guess it's case statements, or similar to unrolling an inline for loop that looped 1 to 100. So it's like a for loop that's been inlined. Okay, so you have all the jump to basically case for every single value you passed in to 100. Otherwise, it gets an issue, an error. And you process arguments, and then some number is parsed from the string that was brought in from the command line. Okay, that makes sense. Dynamic dispatch for enums and tagged unions. So dynamic dispatch is just a way to basically call a specific function given the type that was passed in. But it says for enums and tagged unions, so I'm kind of curious how that's relevant. Okay, so we have a function called iterate that takes in a node and an index, returns an optional node. Okay, so they do inline 4, which unrolls it, I guess. And okay, so you go through all the fields, and because you have this type info thing, it's an enum of type tag. I guess we don't have tag here. And we get all the fields. This gets enrolled. I think this could actually be useful for a parser as well. And we convert into enum of the tag and the value of type tag given this value. And if the tag is equal to base.tag, what is base? Did we get base anywhere? I don't know where base comes from. Oh, here it is. It's the node. So if the node's tag is equal to this particular tag for the field, I guess, return field parent pointer. Oh, this is looks like this is recursive. Interesting. I wonder if that means it gets unrolled. It is recursive here, but actually gets unrolled. Not sure. Yeah, because it looks like something like that. Oh, this is before. This is how things were before. This is how we have done it before. And then this is before, then after is much simpler. Whereas same definition of declaration for the function, same type and everything, same parameters. Now you have a switch statement instead of a for, and it just generates all the different tags automatically for you, right? Given the base tag. And, well, I don't know if I shouldn't say that necessarily. If this is called a compile time, it's going to generate, it should be generating the cases for each of the enum values. And then it'll recursively call iterate on the index, wherever the hell the index is. Yeah. So I guess it just iterates on the node. Okay. It says we cannot use the feature in the standard library of self-host compiler yet because this feature is not implemented in the Bootstrap compiler. The next steps to accomplish this will be enhanced has to see back and until we can replace the Bootstrap compiler. So it looks like this is not supported yet. Cool. That's interesting, but not something we use. Equality testing with error unions. I'm going to skip past that. Pointers to 0-bit types. Before, a pointer to a 0-bit type was itself a 0-bit type. Now pointers to 0-bit types store addresses the same as regular pointers. Cool. This change is unlikely to affect many codebases, as a use case where it might be relevant is representing a struct that has a variable size last field. Okay, so not too important. Minimum to maximum, related min-max. Okay. Remove type parameters from built-ins. The following built-ins no longer have types as the first parameter. Okay, but could be useful. Runtime array concatenation and multiplication. Oh, this is relevant. So the plus plus and the star star operations now support runtime known operands as long as the length is compile time known. So we got an array 1 help dot star. Okay. For array 2 is a string dot star. Then we got array 1, the array length -1, so the last element -1. But I don't know what that does. Oh, it goes from OP, so P to O. Okay, got it. So you just decrement that character. Then we memory swap array 2 first element and the last element. So exclamation point goes here, then we get a gap here, and the final one is array 1 plus concatenated with array 2 concatenated with this. That's obvious. So I guess this didn't work before. Okay. So there might be a breaking change. It could comp time scope. So you got foo returns a string. Cool. And then foo is the result of foo is concatenate with bb, and you just test the length. That's technically, is it 3 in this case? Or 4? I always forget what zig is. Error unable to resolve comp time. So I guess it doesn't matter. But it can't resolve this at comp time because it's not marked as comp time. I don't know. Yeah, okay, cool. So I guess this worked before, it kind of was implicitly comp time, but now it's not, so you have to be explicitly comp time. Okay. I don't know how relevant that is to a lot of what I'm doing, but I'm sure at some point I would run into it. Address of temporaries now produces const pointers. Okay. So originally we were allowed to get an arena allocator, given a page allocator, and I think the arena allocator is basically a bump allocator where it just keeps bumping the last end pointer. We use that a lot in the example in our code. So we try to create a new int 32, assign its value to this, to 1 2 3 4, and it looks like it fails. Found a const heap arena allocator. So we found that it's const pointer to const values, not a const pointer, but pointer to const values. So because of that, it's a pointer to const values. We cannot modify it, right? That makes sense. So you get this error. Yeah. Because it discards const qualifier, because it's cast, I guess. So Zig does not, 0.10 does not allow this. Addresses of temporaries produces constant pointers for safety reasons. Okay. To fix this code, extract the temporary into an explicit var that makes the mutable temporary more obvious, which is safer. trying to process that in my head. Is it safer because you don't mark it as const? I guess it kind of a lie. It looks like a lie, if you mark it as const and still can modify it. Okay. So you must be explicitly marking it far, I guess. Yeah. So you got a stance init. So, oh, okay. Got it. So this itself is a temporary that then you get the allocator from. Right? This whole is, when you call this a init function, you create a temporary because you're not getting the value returned here. You're getting the allocator that's returned, and the allocator itself is const there. Okay. What they're doing here is you're actually saving that temporary to a variable, and then you get the arena allocator after it. Okay. Cool. Standard built-in compiler backend. I'm gonna skip that. Skip that. Address spaces. Might be interesting, but disallows leading zeros. More calling conventions. Okay. Inline assembly. Boolean logic with comp time right hand side. Foo and false as well as bar or true are now comp time known expressions. The left-hand side is allowed to contain runtime side effects, which is preserved as expected. Allow code like this to compile. Looks like you get foo and you got false and foo. This works already. Okay, and then foo and false, which means it should never execute though. But yeah. So I equals to 1 because some reason. No. You get a writer, you print this value where I is equal to, it's a global. And the main executes, foo and false. This should not execute, right? Because it's going to early out because of the false. And then foo, this allows you to run foo. Foo gets executed, so it prints out this value. So it only prints once, I equals 1. Makes sense. I guess this was an issue. Bootstrap compiler. That's all interesting stuff. So self-hosted compiler. So what else do we have up in this list? Do I really want to look at anything else? Bootstrap compiler, self-hosted compiler. So time to upgrade. What I'm curious about this. One option you have is to simply wait for 0.10.1 or even 0.11 before attempting upgrade. I fully agree with that advice. Okay, this gives you a smoothing experience, letting others more brave souls, so other people can try it, find all the problems, make all the mistakes, and then we'll receive the benefit of that. Okay. So skip all that discussion. How to upgrade? Don't need to develop BIC translation. Okay, let's go back to the top. What else we got? Language changes. Okay. CABI did a code generation. I'm curious about this a little bit. Default backend is still LLVM. Zig is starting to is investing in providing its own code generation. The primary motivation for this is compile time speeds. That would be great. There's a lot of benefit to providing bootstrapping process that does not depend on C++, all of which LLVM require in order to build. Yep. Further, there's a value in providing healthy competition so the compiler backends do not become monoculture. As a point of comparison, a stripped release build of Zig with LLVM is 169 megabytes, while without LLVM, it's only 4. That's nice. Wow. WebAssembly backend. Cool. C backend. We got x86. Self-hosted linker. There's going to be a linker as well. Cool. Cough. I don't know what cough is. I guess that's a binary type. Okay. Linker performance. Okay, I don't care about the performance stuff yet. Math. Bunch of stuff about math. Blah, 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 blah. Okay, we'll get back to the top. That's all cool and stuff. Yeah, I'm sorry, boring for anybody who doesn't care about all this compiler stuff, but it is what we're doing for now. by the way. I really would like to improve my stream layout. Unfortunately, the aspect ratio of my monitor doesn't make this layout work so well. I wish I had a little, slightly taller monitor, to be honest, and it would be great for writing code as well. Honestly, the whole widescreen shit is not good for coding. I want a tall boy like this. It would be quite nice. Of course, I can rotate these. I can rotate most monitors, but then it's too tall. It's not wide enough. So I'm not one of those programmers who can handle that. Like the portrait mode or whatever. Yeah. Oh, awesome. Good to hear, Mighty Sandwich. Good to hear. I'm gonna need some more water so I can talk more without my throat getting dry. It is quite parched in here. Yeah. Okay. Okay, we have tool chains. What is it? Tool chains. Oh yeah, we have the drop-in replacement for different programming languages. Cool. What's in the roadmap? Okay. Yeah, so one of the big goals of Zig language, which I don't think is going to really happen, we'll see, is not to change the language specification after 1.0. But of course, they had the freedom to just never release 1.0, right? Like 1.0 could be decades in the future if they really wanted to, right? They could be making as many changes as necessary until the cows come home, but they don't have to release 1.0. No. Okay. Awesome. Well, let me close this real quick. I'm going to review a little bit of what we've done up to now. I know it's been months since I've done any work on this. I think September, the end of September was the last time we made changes. Hopefully, I can stream quite a bit this week. Yeah, let me get some water. I'll be right back. Turn off the camera while I do that. Okay. I returned. A little chilly in here, but I prefer not to use the heat during the day. Okay, yeah, so the last few things we did last month, looks like we had, I'm going to read through some of these changes here just so to refresh myself about what's going on. So we supported drawing flipped and scaled sprites, supported hot reloading game assets with Control F5, added support for drawing hitboxes. Cool. Fixed the bug where two-player would not get hit when player one is active. Supported flipping characters to face their opponents during idle. We don't have any way to indicate. Oh, we do have a way to indicate flipping. So I think I just want to look at that real quick. I think we did that right. Is the game running? Oh, yeah, there you go. Yeah, so when we're over here, man, the character speed is slow. Yeah. I think I would definitely want to. Oh, I don't even support diagonals in controller. I want to change that. Okay. Hold on, let me write a little note here. What is today's date? We got the 19th here. Okay. These are all like future stuff. I have to go back and deal with that. But because I think it works with the key. Oh, it doesn't work with the keypad. Oh yeah, I don't support that at all. Huh. Okay, we'll change that. But okay, we had support for controller 2 input. Good. Added debug validations for the current action. We have that. Added debug statistics component. Statistics component used in visualization and other those things. Okay, that was all like the frame display. So we're returning back to idle at the end of action. Great. Action transitions, improvements. I don't know what we did there, but I'm going to improvements. That's a bad comment. I should have wrote a better comment there. Okay. Well, we adjusted the reaction system to go back to standing, I guess, at the end of it. Okay. I commented some stuff out here in the timeline. Not entirely sure. I should have wrote better comments to remind myself months down the line what we're doing. Okay. Sorry, my voice might be going out. I hung out with some people last night. I may have worked out my vocal cords a little too much. Or I should be drinking something warm instead of this cold water. Okay. Cool. Well, I had this stuff on my agenda for September, like action timeline not determining idle, hit stuns. I don't know if we actually supported that or not, but also had like block stun, block reaction. I was thinking of working on that. Launch physics, launch reaction. That's also kind of cool to work on. But let's just quickly fix these diagonals. On the diagonal, the diagonal jumps. So it's probably just a simple problem of using if else in the main game loop. Say controller. I forget exactly what our sorry, I don't get layout. Why can't I get a layout? No symbols found in document game about Zig and Nande. What? I thought I could easily find the layout. Well, I don't know why things are broken. It's been a while. That always happens when you come back to something after a while. Everything just breaks. Yeah, I don't know why the outline stuff doesn't work. Oh well. Anyway, we got pull game input. We have gamepad if, okay. We have up, down, left, right. So actually it looks like we have no problem in storing that input, right? It's probably just don't have code for diagonally jumping. Okay. So our state machine, no. Okay. Up, down, true to do. Where do we actually read this? Our input command. It should be an idle. It should be in our common states idle. Can I get an outline here? No outline. What? Oh, I really would like to have an outline. Okay. I need to look into getting that working again. Okay. So we have standing here. On update, we should have translation into jump, right? So we just have up. We don't have jump forward, jump back. So here's two different ways we could handle having jump forward, jump back. We could have three states, right? We could have a jump forward state, jump back state, and jump neutral state. Jump action. But in our case, we have the same animation. Everything behaves almost exactly the same except the physics, which is forward momentum. One way to do that is on exit, we could set momentum, set the velocity to plus or minus a value, right? Or you could pass in some value into context that defers the velocity being set. Now in fighting games, typically you have jump startup, right? Jump startup is the amount of time you're still on the ground before you actually go into the air. Why do fighting games have jump startup? Well, you want to avoid the problem of players escaping ground combo situations by holding up. If you instantly went in the air when you held up, you could get out of some of the most damaging combos. Or more specifically, when your attacker is attempting to go for ground-based combo, and if it's possible to instantly be in the air by holding up, it's possible to escape that situation if you know it's coming. It would be highly advantageous to do so. So what fighting game developers have done is they implemented something called jump startup, which is the amount of time you're still on the ground when you press up. That way, attackers can catch you for those few frames while you're still on the ground and do a ground-based combo. So during jump, normally you would have a few frames of jump start up. So that could be implemented also in a few different ways. You could have multiple states, right? You could have a jump start frame, a jump start state, then a jump state. And actually you would have a landing state too, which is another thing I'm not going to go into right now. But now you're seeing kind of state explosion, right? You could potentially have, if you're at neutral, if you're at standing state, walking, whatever, and you hold up forward, well, you potentially need to tell the state machine potentially needs to go to a jump forward start, then a jump forward, right? Or you can make that one state, jump forward, as a single thing. And then you could have 3 states there, 3 actions. Or you could have a completely single state that takes care of all the cases, but at some point you need to apply the physics, the physics properties, which would be after. You don't want to do it on frame 0 because, again, you have that jump start up. If you did that, the character is going to start sliding on the ground before they go into the air for a jump forward or a jump back, for example. So you need, if you have a single state at some frame where you're now off the ground, you need to apply a forward or back velocity for the jump back and jump forward. Now, something needs to indicate, first of all, what value to apply there for the velocity. You could either do that directly by storing the velocity in some temporary place. Now, if you did that, some piece of code here, probably in our standing action before we transition, would have to store that velocity given this condition, such as, assume we had like context input command dot up and forward. This is just an example, right? You'd have something like up. I probably want to do a switch here, but if you had like dot forward or whatever. Did I not? I did left and right. Well, I should change that actually. But we'll get back to that later. So here you'd potentially be like, okay, context.physics or whatever, physics components. I thought I had a physics component. I forgot what we have in our. Let's assume we have a physics component in our context, and we have like a velocity or something. Velocity dot x. What velocity? What is? Anyway, dot x or something would equal like 5, right? You could directly set the forward velocity to some value here. And assuming our context stuff here is persistent storage, we start thinking about networking, right? How that value gets replicated on the other side. Or when we're doing rollbacks, how you maintain that value so if you rewind and rerun the simulation, it goes back to the previous value. So it works, right? That would function. But I like to start thinking ahead of time where potential bugs can happen with this, right? Yeah, it's fine now. We have one source of transition to jump, right? But what happens when you want to jump transitioning from the very last frame of attacks, right? Or any other action that's not idle. Well, now you have to store that value. You have to set that value from each of the transitions, which means you either do it manually like this at each transition, place of transition, or you make a common function, which would reduce the amount of potential differences. But still, you're setting a value ahead of the state. And honestly, the state itself, when you're programming this, should know what value to set for the forward jump, not the previous state. Logically, it should be associated with the state directly and not with the previous state. Now, your game design might be different, right? You might get different jumps depending on different situations. Then it becomes more logical to have different velocities and things, So option number 2 is the state itself needs to set that value, or it's going to read an external setting, a property that we've kind of configured elsewhere, which is ends up being the more common thing that's done in fighting games. You want to have this common functionality shared among different characters. So the code is the same, but it's reading an external property such as the jump forward speed, so that you can vary those values, configure those values depending on the type of character you're making. Because fighting games tend to have shared system mechanics like this. Hope that makes sense. So, to me, that's the way we should go, right? But still, we have the problem. How do you indicate to the state, to the action? Should it be a forward action, a back action? Again, if you just did a transition into one of the three states, jump forward, jump back, neutral, then that solves that problem. You don't have to store any particular flag to indicate to the state that you're doing a jump forward or jump back. Now, which way should you go? Should we go through multiple states for each jump type, or should we have a single state? For this kind of project, I would love to err on simplicity, to have less states, if at all possible. But again, we have to introduce some variable to indicate which jump we're going through. So again, that adds more. Every time you add a variable, you have to think about potential bugs, right? Because this means that every point we transition to a jump, there needs to be an indication of whether it's going to be back or is it going to be forward. It's going to be neutral. That value needs to be set to the right value, right? You can't just ignore it because it might maintain the value from the last jump. And you can imagine in the future, okay, what if we add jump canceling? Well, we coded the jump forward. We supported the jump from canceling, but we forgot about setting that flag. Then it's going to maintain that value from the last time we set it. Unless you have, and I've seen this before in games where at the start of an action, you just reset a bunch of these flags. But then again, potential bug. When you add a new flag, if you forget to put it in that place where you reset all the flags at the beginning of an action, it's a problem, right? Now we can reduce that problem by having a single flag variable that stores a bunch of different flags, and you just reset that single enum value. But eventually we're going to run out of flags, right? We're eventually going to have we could have up to 64 bits for a single enum, I think, in Zig at most. Each bit indicating a single flag. So you can see how the complexity, there's many different ways to skin a cat, so to speak, but every way is going to be bloody. Well, unless you drink the blood, but sorry. That analogy is probably not the most family-friendly one. So yeah, I'm thinking of erring on the side of using a flag to indicate which jump we go to. Maybe in the future we could think of a better way of handling this. Right now, making new actions, new states, requires a little bit of boilerplate, and I don't want to fill up our state machine with a ton of different actions. I'm gonna get some water. I'll be right back. Okay, I'm back. Yeah, so I think I want to go the path of adding a flag to indicate which type of jump it is. In my ideal world, I wish I could have central place to store the flags, but indicate which flags are relevant to each action. Like I would only want jump flags to be relevant to jump actions, right? Other actions like a punch should not check the jump flags. That's one way you can reduce potential bugs, and also indicate intent to future programmers, including yourself. Yeah. But for now, I don't know any way to do that with the Zig compiler or any compiler, to be honest. So mathematically, you could indicate it as like, okay, this takes the subset of flags uh, of this action, right? That would be clear intent. Maybe something like a Haskell or other functional languages could do that really well. Like, okay, this function only takes this subset of flags, and that gets passed in when you call that action, or you call the transition to that action, or whatever, or whenever it's ticked, meaning updated. Okay, where are we going to store the flags? Well, it's going to have to go in a component because it's going to be per character, right? It's going to be variable data that changes over time. That's what variable means. So we have timeline component, physics component, blah, blah, blah. We have a stats component that's not relevant to actual gameplay. What other components do we have? I thought we had like a gameplay component kind of thing. We did not make that, or like a combat component, action component. Oh, we must have that because we have to store the action somewhere, right? It's been a while, so. Okay, we had reaction component. What the? That's the problem. A component is such a generic term, so it easily pops up all over the place. Let's go in our state machine real quick to remind, so I can remind myself how this actually works. So we handle transition. We get a process or a context. Character properties, etc., etc. On transition, our context has a transition, so we have a next state. Yeah, where's next state stored? Next state is in the combat state context. That's what I was looking for. Okay. Oh. Well, I'm very happy, Chemic Man, that I can explain something in somewhat a coherent fashion. Okay. So our combat state context stores multiple components, but we don't necessarily have a how do I put a combat component? Do we want to add a new component overall? Well, let's see real quick. So we have timeline components, reaction components, input components, stats components. Yeah, we don't have really a good place to put it already. I'm already getting annoyed that we have magic numbers here, right? So I'm just gonna say equals 10. Does that work? Oh, I don't. Can I have a const there so I can replace all this with. Obviously, input component is different, so I'm gonna move that down. That's very specific to. I'm gonna call this like. I don't want to call them right now. I'm just going to global components. Okay. Oh yeah. This syntax, I wish we could do better with this. if there's a better way to handle this, I'm all ears. We're just saying like, hey, we have storage for this much. Okay. Does that work? Can we do this? Const max entities, or do I have to specify like a size type? Oh, I broke something, right? Oops. And which I can go to there. Just link me. Open that. Open file editor. Yeah, there we go. Go to 95. Thank you. Yeah, this is the code I just added there. But yeah. Need a lozenge. Talking in cold weather is not great. Okay, cool. That just works. What shall I do next? Oops. Man, I'm hungry. Talking makes you hungry. Okay, so again, there's some boilerplate with adding new components. I could easily just add something to an existing component. Like I have this kind of stuff here, like my combat state contacts. I need to add any new component there as well. A bit annoying. Dug myself in this own hole. But yeah, for now, let's just add a new component. I don't know. Combat flags. Combat flags component? I don't know what to call it. Combat component. Oh, it's called action flags. Okay. Okay, I don't know the good name. We can rename this later. I'm only making a struct to be consistent with everything else. Actually, I don't have any enums. I should have enums in my project. I just want to review them real quick. I think, oh God. Yeah, unfortunately, it's searching all the files in this other stuff I've included. That's gonna, okay. At least I have it in my Zig notes. Just remind myself how enums work. So you do something like this. Any other underlying type there. Oops. Oops, I don't know how to zoom in. Anyway, I made the text smaller. Control, I thought it was Control Shift plus, right? Oh, there we go. Okay. Let's just go ahead and make this here action flag. Yeah, for now, let's call it jump flag. That's probably smarter. Let's have a jump flag, right? And jump flags there, and we want jump neutral. I don't know. Jump neutral. Jump forward. Jump back. Backwards. Jump back. Okay. Yeah, and I'm gonna leave out the rest of it. Right now it's a U32. I can make a U64. Honestly, I don't know if we're gonna need that many flags for jump, but for now we just have the single jump flags, and it's going to be the type jump flag. Oh, and I guess we could default to none just to make things easier, so that this certain not having no flags be none. But I have to make this 0. Can I do this in Zig to make the first thing technically not be a flag, but the empty state of flags? Let's double check Zig real quick in the documentation so we find anything about flags. And I don't want to look at this version. I want to look at the previous version. Okay, enum. So we have enums. Can we assign default values? Because I want to assign it to 0, not 1. Enum literals. Okay. Non-exhaustive enums. Okay. Can I not have flag? Bit flag? Flag. Do we have flags? In Zig. I may have looked at this before. How do I implement flags in Zig? I guess the default value is 0, so it's not a problem. But we need to make everything like 1, 2, 4 to be a bit flag. Hold on real quick. Zig bit flag type. Do we have information on that? What have they suggested about bit flags? Yeah, I try to ignore type being back. If you type backward, yeah, it's backwards, but so back is better, I think. Forward, but then you have forward. Go forward. You don't say go forwards. Oh, yeah. Forwards is like a verb. He forwards the mail. I don't know. Yo, what's up, Joshua? I'm sorry I didn't see your messages until just now. I have not used Zig since September, into September, for any other project. Like any language, it does have its warts, but trying to work around them. Yeah. So let's see. Zig provides enum flag set as a safer and more economic way to implement bit flags. Also, this is just the complementary operation bit flag wise is not restricted to bits used. I see what people say about this. Let's see. I don't care about that. I'm trying to see if anybody suggests anything to do. Oh, someone says packed structs and Zig makes bit flag sets trivial. As we've been building mocking, we've been so someone's making a game engine in Zig. We've been using neat little patterns in Zig that enables writing flag sets more nicely. I used Golang in the past, but I think the problem with Golang is it didn't have. Again, what was important to me is compile time code execution, or at least back then it didn't seem to have anything like that. I need to be able to like reflect on data structures in the language itself, so I can generate serializers and deserializers for game data. So I don't have to manually write those things, right? It's much easier if I could just iterate over all properties in a struct and generate the data. And also, my feeling was like Golang is language more built for concurrency. That was the kind of primary focus. At least when I was looking at it like years and years and years ago, like back in college. Okay, and again, Zig is still in development language. It's very much not production ready. Even the creator, Andrew Kelly, often says like, "Don't use this in production," even though people do. Yeah. But I do like its feature set, so that's why I'm using it. Okay, pack structs. This is okay. We looked at pack structs before, so we have a clue how this might be used. Red, green, blue, alpha, padding. All bulls. So basically, this diagram makes it appear. Yeah, all these things are named. All these bits are named, but it's pretty much just an unassigned int 32, which is what an enum ends up being in C++ when you're trying to use it as a bit flag. So we could write these flags like this pack struct, assigning each thing to a bool, because it's literally just a single bit. Oh wow, so yeah, you could just make a mask like this. You just assign the individual. Cool. So let's look at this real quick. So okay, I'm gonna check the comp time validation. Making sure that our flag ends up being the same size could be tricky, but what if we count the number of bulls wrong? So what? Okay. They're talking about like getting the size wrong. Okay, cool. So you can do a comp time assert on this, making sure the size of it is equal to this and this. Cool. So first I'm just going to go ahead and copy this. So get rid of this. Well, we'll rename the jump flags thing here. So we're going to make jump flags. I don't know if I should call it jump flags or jump flag. I honestly hate it. Let's start with jump flags here. Just copy this, what we have here. But none should be a special case. I don't know how I'll handle that with a packed struct. I guess it doesn't matter. We don't need to have a none. We could just check to see if the value of the whole thing is 0. Then that would indicate that it's empty. And since it's a function, we could just make a... Sorry, since it's just a struct, we can make a function that checks its value. If it's 0, then we're good. That's because if it's just going to be an integer, we can just check to see if it's 0, and that'll indicate that it's none or not. I think that's fine. So yeah, so instead of this, all these are just bool. All right, doesn't really matter. And there's probably some way we could automate, not automate necessarily, but compile time, generate the right things. But for now, we're just going to do it manually. In the future, maybe. Oh, we don't need none. Okay. And padding, yeah. So we have to manually do this at least. So we have 3 elements, and we have to update this each time. So we have 28 bits afterwards. It's not right. We need to have 29 bits afterwards, and we can just keep this comp time assert stuff. And just real quick, I want to make sure that this actually works. This may not actually work. We may have to do something special here, but I'm just going to go ahead and give it a shot. Well, I created a pack struct. So I don't know if you just saw the previous window I was looking at. Hold on. 46. Oh, should this be... I don't know if you saw this window, but this article is suggesting using a pack struct for implementing bit flags. And that's what I'm trying right now. Oh, sorry, we need to include. Oop. Const. What is it? Just standard date, I think. Is that right? Oops. Is that the library? Is it fine if I use... I probably should look at my other code. Yeah, that's right. Okay. That's the fine right there, so it should be fine. Okay, so that compiles at least. That's good. But there's something else here mentioned that I'm interested in. Explicit backing integers for pack structs. It's worth noting that in Zig 0.10, the new self-help compiler has supported explicit backing integers for pack structs, which will simplify this even further. Okay, so we can't do this yet. Instead of manually adding padding to make up 32 bits, one could simply write pack struct. So that's a good reason to use the new version. We don't have to manually put in the padding to make it an integer under the underlying type integer, or int32, unsigned int32 in this case. You just write it as a pack struct and it just handles all that. Okay, actually I'm going to save this into my Zig notes, and I'm going to call it bit filled, bit flag, bit filled. I always forget it. Bit flag, bit filled, bit flags, bit fields, because I'm not sure. It gets named different things here. So I'm going to say using, what's the name of the article? Okay. Cool. That's just notes for me. Yeah, okay. Personal notes for remembering this kind of stuff. Okay, and then there's some interesting stuff at the end here saying, but C has had bit filled since forever. Because in C, this is kind of trivial to implement, right? You just basically use OR operations to set multiple flags on an integer, given that their power of two values. Okay, let's see what it says. Shortly after posting this article, I've inundated with comments proclaiming that C has had bit fields since forever. First, I'd like to say I was not aware of C bit fields at the time of writing. Interesting. I simply had not ever come across use of them. Really? It's pretty common. Secondly, I'd like to question is, if C has bit fields, then why do you seemingly all modern C does not use? Why does it expose integer types instead? Oh, that's right. So yeah, it doesn't. So I got it. And then I found the answer in the specification. If insufficient space remains, whether a bit field that does not fit put does not fit is put into the next unit or overlaps adjacent is implementation defined. Okay, so the order of allocation. Sorry. Cold air in here. The order of allocation of bit fields within a unit, high order to low order or low order to high order, is implementation defined. The alignment of the addressable storage unit is unspecified, so that's not great. You're going to get different behavior depending on which compiler you use in C if you use the bit fields. And somebody writes, the in-memory representation of bit fields is implementation defined, okay, as we know from what was listed here in the specification. Therefore, if you're calling into an external API that takes unsigned int32, like in an example without an explicit remapping, you may not like the results. Okay, yeah, so you might get different behavior, and the API may not expect what you're giving it. In practice, everything you're likely to come across will be little Indian nowadays, and the API you're using will be most likely order your struct from top to bottom in memory. Okay, so they will look the same most of the time. However, it's still technically not portable. That's right. Okay, and he's just saying stuff about C bit fields. Okay. Yeah, so he's just complaining about masking and stuff like that. So this may be the right approach to do it, maybe the bad approach to do it in Zig, not Zag. Looks like there's a Hacker News article here commenting on it. If I wanted to learn more about whether or not this is a good approach, maybe this is worth reviewing. Some people are commenting on stuff. I don't necessarily want to read it right this moment. Someone's talking about their own language. Okay. Okay, so let's just go along with this approach for now, and then we can change our opinion later. We always reserve the right to do so. Okay. So we have our action flags. It's interesting we don't store it as an int directly, but that gives us type safety. Okay. So we do have this now. Jump flags. Is it? Wait. Why did this compile? Because this probably actually is a problem, and we're going to see very soon why. Hold on. Actually, I'm going to do stats component because I'm not using that in many places right now. So I'm not use it there. Let's go ahead and add action flags component. Action flags components, and I'm just going to go ahead and just copy paste this here. And there should be action. Hold on. It shouldn't be action flags. It should be action flags component. Let me close these other documents. do action flags component. Same thing, action flags component. Okay, now I wonder if it's going to give an error. Now that I've actually explicitly used it. Zig kind of silently doesn't throw errors when you don't use something. Yeah, here we go. Expected flags found comp time int. This is what I thought was going to be an issue. So, I guess you can do it. You can just say jump flags. Is it how we? Or we can just do this to get the default, I think. Oh, the problem is we don't explicitly define everything as false, because otherwise we have to be explicit about what flags are set, which is going to be a huge pain in the ass. Okay. Wonder if that's going to fail or not. Explicit. Oh, it's still throwing an error. Actually, do we need this? I think we need this in Zig. We have to be explicitly state what the initial value is. Yeah. It's probably going to say that in the error too. Missing field, jump neutral. Yes, so we have not set those. So, whoops. If we set these all to false, and it'd be nice to do some kind of comp time stuff if I could, just to define new bit flags, but for now, this should work. Doing everything manually first and then automating it later. You can't automate something you don't understand yet. Well, you can do it, but the results may vary. Okay, so we've set that. That's great. And a way we can test, we probably could test whether or not something is none by doing something like, is jump flags equal to, like, flags equal to jump flags, right? Something like that, right? Yeah. Anyway. Yeah. Give me 1 second. Be right back. Alrighty, I think in about 30 minutes I'll cut this off. I'm getting kind of peckish here, so I want to get some food. And then I'll stream some more later or tomorrow. It's getting kind of late today, so not today probably. But yeah, tomorrow. I don't know if I'll stream every day this week, but I'll give it a shot. Okay, so right here we have our action flags component. We've initialized it. What else do we need to do? We had a search here, right? So we assign the stats component like that, action flags component like this. Where does it actually get used? The stats component. Stats components. So how does it get used? Well, in some place we just grab it from the game state. Oh, sorry. Yeah. Interesting. And we use it elsewhere. Yeah, it's just game state dot. In the game state we have our thing, and that's just in the reaction system. Okay, that's actually not as interesting. I want to look at where we assign it for our action system. So we have something like this in our action system where we have a context, and so far we don't have a context value, a context reference to our action flags. So we're going to call it like action flags component. And then we'll have to store it here in the action components. So that gives us access to our action flags inside of our context. We don't actually have a value for this yet. Can we just go to the value? Well, okay. So where's our combat context? Oh, no. Okay. Okay. Yeah, let's just start for this real quick. I know our context is set up somewhere. Not there. Oh, here, right? Okay. So action flags component. It needs to be assigned to action flags component type. It's completely undefined as we expect. It will be assigned later. So that should give us availability of it. That looks fine. Maybe. Okay. Everything looks good there. Let's compile it for posterity's sake. Oof. So, yeah, probably. I wasn't surprised with an error. Expected. Yeah. Open enter. Also, we just control click together. Great. Fantastic. That's going to speed things along. I just forgot semicolon. Okay. So we have our flag. So what we need to do is set the flag when we hold up forward to give us forward jump, and then we have to assign the velocity, the x component of the velocity, to some value inside the jump itself. And same thing for back. We're going to ignore the jump startup frames for now. We'll get there. Okay, so we just want to make use of this flags that we've prepared. And also we need to make sure we set that just in case. Honestly, it shouldn't be used by anything but the jump, but you never know. You never know what future me is going to do, and I don't know what I'm going to do. Yeah, because you're always going to forget context of this stuff. So when you're designing, your game's code architecture, you really need to think about other programmers, yourself, not understanding the context that this code is written in. So you need to be as explicit as possible about how things need to be used. If I want to be really pedantic, I can put asserts everywhere to check myself, right? To indicate to my future self, to other programmers, what I was intending. Okay. So yeah, let's jump in our common states real quick and add that flag to our standing state. There's going to be other places where you can transition to jump, but for now we're just assuming it's idle, our standing action. Yeah, common. Oh, that's right here. Common states. Okay, so we have up, but we have no up forward, right? And so we can do it different ways, but for now I'm going to just check it in here. If up right, this is not going to work for back and left and right because we don't have a forward input, right? We only have left and right, but we haven't supported that yet. So it's something we have to consider in the future what to change. So I'm being lazy and just doing this for now. So we have context that action flags component dot jump flags dot jump forward equals to true. We can do it that way, I think. And I think that syntax works. If it doesn't work, we'll fix it. Yeah. No member named jump flags. I don't have the jump flags, or I don't have action flags. No member named jump flags. What did I name it? Jump flag? Oh, duh. Okay. That's why. Consistent naming is important. Naming rules. So right now still can't jump while walking forward. Part of that reason is right and forward have priority. I'm going to make that not priority. I'm going to make that less priority than everything else, just by changing where it is in the if-else tree. So up Honestly, attack should have the highest priority. And we're going to change that here just to go ahead and do it. So attack has the highest priority for executing, then jump with up command. Then we have the jump forward here. Okay, so within the jump state itself, we need to check this flag, right? So let's go here. So we should have jump state. So on start, you see we have a y velocity being set, right? That's up and down. And then so we're going to check the flags here for now. Okay, so if this is set to true, we will set the forward velocity to explicit value. So we're in like the thousands range. So if we want to move, like, say 1 centimeter per frame, it would be 1,000. But let's just give that a shot real quick. Yeah, knowing that, yeah, write everything down, comment everything, though I'm not commenting that much right here, to be honest. So I can jump, but still, I can't get to oh, because I'm walking. So again, yeah, we've copy pasted this stuff into walking previously. We don't have a shared function for doing this stuff. Oops. Because I'm walking, I'm in the walking state. I can't transition to our new code because that code is explicitly only in the standing state. So I either, I could just copy paste this real quick into walking. Honestly, I should make it a new function. Normally that's what I would do. So I'm going to do that. Do I have, so we have common transitions. Okay, so got it. So common transitions include walk, doesn't it? Yeah, right, left for walk. Blah, blah, blah. So we need common, because you can't transition to walk from walk. Yeah, for now, let's just put everything here and then go back to idle and handle it. So as we see here, up and attack, less priority. We've already made a function here. Let's fix the priorities on that real quick and replace the idle one, which I was intending to do anyway, I believe, but I just completely forgot about it. Oh yeah, this should be completely opposite. God, I wish the auto formatting was better here. Okay. Oops. Okay, we got everything here, and then we have something. We're already using this on other places. Yeah. We're only using it on the reaction right now. We're not using it on walking. So let's go to walk equals, oops, actually standing. Let's go to our standing struct. Replace all of this with our common transitions. And I'll probably have to pass in this context, I think. Maybe that's how it works. Yeah. And then, oops. Oh, we have common idle transitions. Now I'm not even calling this from somewhere. Oh, okay. Only check for idle transactions when. Only check for idle transitions on the final frame. So we don't actually want to call this on idle because that would only be for actions and things like that. And we already replaced it with standing. Now walking forward, we need to replace all that with. Do we already have that here? What? I thought we can go directly into attack from walking. We can't currently? Let's give it a shot. I really thought I had put all this in the other states, but I had not done it yet. Okay. So, yep. What is attack? This attack. Yeah, you can't attack while walking forward yet. You can see. So, it's easy enough to do. Instead of just returning to standing, we're going to prioritize common transitions. And honestly, we probably should return a value from that. But, yeah. So, what should we do? Okay. Yeah, we honestly should be returning a value to check whether or not we've transitioned so that we can not do this, because otherwise, if you release the button, it's going to prioritize standing, which is bad because you'd go to a frame of standing and cancel out any transitions to attacks. Let's see. Oops. Where are we at? Yeah, see how we have void on everything? You know, we'd have to do something like true. Oops, not true. Bool. Is that going to break everything though? Let's just go. Let's just say return false for now. Make sure that doesn't break everything. I forgot if you can discard return values in Zig. I think you can't. You can't discard. You have to be explicit about it if you want it. Yeah, value ignored. So I forgot what the keyword for that is. So we have to go through here and update all these, right? Kind of annoying. Though, hold on. It can be kind of annoying. Just kind of work around for now. Don't necessarily need this. Make the void. Go to here. Context. What are we doing here? Is this standing? So, oops. So like on walking forwards, I mean, one way we could do it literally is just go if context transition, then return, right? Kind of a hack, but that would work, maybe. Usually I would return a value from any of those transition functions. So look, you can jump forward now. Woo! And you can walk and attack, which you couldn't do before. But jumping back doesn't exist yet, right? So what happens on the other side? See, on the other side, see how I can walk? Right now, walking doesn't auto flip. Well, it did auto flip there. Oh, because I didn't release it. Okay. So I don't know why it auto flips on going left. But anyway, I have to look and see why. But you can see I can jump forward. Oops. Fell through the ground. That's fun. Yeah, I think right now I fall off the ground with attacks. No? Okay. Interesting. That was an interesting bug. So you can see how we do jump forward, right? And it's going to be the same thing for jump back. Common transitions. Is there a go-to? I really wish I had a go-to implementation. Okay. It's a lot less convenient. Okay, so we have increment upright. Wait, why did that work, to be honest? That's weird. That's really weird. Cause yeah, I did not put that up forward thing. Jump forward. Yeah. Yeah, I don't have that flag set. So why did it work? The ghost of Christmas past. Oh, because it did not reset the velocity of walking forward. That's why. Right. So what we want to do here is see how we have jump flags. We can do else if this, not jump forward, but jump back. We'll do the opposite there, and then we'd have 0 otherwise. Or, oh, I didn't want to do acceleration. I wanted to do velocity. And then, so you don't even have to do an else. You can just kind of set velocity to 0 like this. well, you're setting it twice, but I don't like having the additional else statement there. Okay. So that should fix that problem where it's not going to be working yet until we actually implement it. Okay. Yep. So I'm holding forward to hit up. Doesn't work. Back doesn't work. So we need to actually set that flag, the jump forward flag, and common transitions. So let's go ahead and do that. So if context.input command, not there, not on the right one. We want to do it up. So if context.input command dot right, we want to set that flag. So action flags component dot jump flags dot jump forward equals true, and then we can go ahead and do left as well. Otherwise, this. Also, another thing is like these flags are not mutually exclusive, right? That's another kind of problem. But with these kind of bit flags, it's kind of hard to set up mutually exclusive things. But won't worry about that today. So we should be able to jump back and forward with this flag setting now. Oh, I put an error. What did I mess up? Oh yeah, it's also jump flags. That's right. Starts with lowercase. I should have been consistent from the very beginning with all properties starting lowercase, because it's kind of like the Zig way of doing stuff. But you live and learn. Okay, so hold forward, jump forward. I get it. Jump back. Jump back doesn't work yet. Why does it not work yet? We'll check that out. Oh, because backup doesn't use the common transitions, right? So, but here, if I'm behind and hold up right, I get the jump. It works, but I can't do jump left. It's because I haven't supported flipping on the inputs yet. That's something we have to do eventually. Something you should have done earlier before doing this, technically, but I wanted to do this because it was gnawing at me. Okay, and yeah, so what is backing? Is it backing up, or we call it walking back? Is that what we called it? Walking backward instead of walking backwards. Okay, so yeah, same kind of similar thing. We could just go. Honestly, we should just do this because we don't need to update this. So if comment has context, actually we call this, we can't actually do an if there. We just call that, and then if context.be transition, and then we just return. Same kind of little hack we did before, to avoid executing the stuff down here. And why is this all weird? Anyway, so yeah, it's also indentation's wrong there. Okay, so this should give us jump back now, because it's the walking back action transitioning into the jump back. And we should also be able to do attack and then go in directly into the jump back and jump forward too. So cool. Jump back works, jump forward works, and we can keep jumping forward. We can keep jumping. Oh, it keeps jumping forward when I hold up back. That's interesting. Oop, now it's not working. Ooh, 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 ooh. Something's not right. It says walking backwards, so it's still trying to do walking backwards, even though I'm facing the other way, because we don't support that yet, right? Gotcha. So I think it's trying to transition and messes up. Let's restart it and see what's happening. So this is how easy it is. So yeah, I can't actually walk backwards right now. You can see we get walking backwards on start, on end. I'm holding left. The problem is it keeps trying to transition with this function call, right? Because we have the input for walking backwards set up there. So what we'd have to do is have a version of this function that doesn't have the walking back. Or we could check to see if the thing trying to transition to isn't the current is not the same action, but that would prevent us from doing the same action into itself, which might be useful for certain cases like fast jabbing. Um, do I want to quickly fix this before do anything? Yeah, we could just quickly check. Got it. This is a longer discussion, so I'm going to kind of leave it here. But this is pretty much what I wanted to do. We'll fix the other part later. But for now, I'm going to get something to eat. Hope this was somewhat educational, as always. Appreciate everybody who dropped by. I know it was kind of a sudden impromptu stream. But yeah, maybe tomorrow. I'm off work for the next few weeks, so I should have plenty of time to do more of this project. Anyway, again, thanks everybody who came. See you next time. Enjoy the rest of your day. Peace out.